today I have really the distinct honor of getting to introduce a person whose work I've admired and relied upon for decades, and whose record of accomplishment is one of decades, and that's Stephen Sheppard. Stephen is a professor of landscape architecture and forest resource management at the University of British Columbia in Vancouver. There, he is the longtime director of the Collaborative for Advanced Landscape Planning. The collaborative has engaged with communities in British Columbia and elsewhere for a long time in employing visualization as a means of doing strong science and assisting communities. Because Stephen's work in visualization has focused on landscape, the way it is focused on landscape has made him a leader in showing how invention of alternative futures is one means of bringing together scientists, practitioners, and communities around something that perhaps none of us would have envisioned alone, but could begin to give meaning to as we look at a future we don't know yet. He's also, as director of this lab, employing visualization, made great use of the way that futures and change over time, the process of change over time, can be made visible and consequently elicit research questions and community actions that might not otherwise be. As I said, he's been a leader in landscape visualization for decades. Among the things I admire most is that as a longtime leader, he does not look backward, he looks forward. And his recent book, released just this year, is a magnificent demonstration of this, Visualizing Climate Change, a guide for visual communication of climate change and developing land solutions. This is not theory alone, though it's based on sound science. It is also based on his record of offering solutions and developing solutions with communities. I'm very much looking forward to what he is going to add to the rich conversation we've enjoyed so far. Please let's welcome Stephen Sheppard.
Thank you very much, Joan, for overly kind words, but I'll take them anyway. Thank you. I think I'm going to come down on the ground, see if this works, and if everyone can hear me. If not, please let me know. And also, if I've timed this right, there should be enough time for questions. And so if there are sort of burning issues or something you just can't live with that I might say, feel free to put your hand up. We may do a very quick one. Quick question, but long discussion we'll perhaps leave for later. Okay. So before I start, I do want to say thank you to Sync, I'm starting learning how to pronounce it properly, for inviting me to join with many other academics, practitioners, and leaders in the field. It's fun to mingle with those, some of whom are well known to me. I've got colleagues here who are doing very similar and groundbreaking work. As well as people from other fields beyond sort of the landscape planning, landscape visualization field where I tend to focus. And I think it's that richness that is really exciting about what SYNC does. So I'm looking forward to further discussions, and I'll probably eat some of the words that I say today when I've heard more from the discussions the next couple of days. So as Joan says, I wanted to talk a little bit about this idea of sort of socio-environmental, socio-economic pathways. Is very current right now with the IPCC, with the new assessments coming up. This recognition that we have to be looking at these interconnections. And I think this idea of future pathways is just fascinating and quite difficult and very troubling. So I want to explore it a little bit more and also look back at sort of where it's come from. So bear with me, we'll run through a few of these examples. So we have a crisis, and that to me sort of drives an awful lot of why 7 or 8 years ago I chose to just say that this landscape planning stuff and this urban planning and resource management, that's all very important, but we're missing the boat here. Climate change is happening, it's happening very quickly. People don't seem to be getting it in terms of policy or behavior change. What can I do as a landscape architect and a planner to help to do something? And so, unfortunately, all those sentiments still are around. We haven't solved any problems. We've solved a few, but we haven't solved the big ones yet. So we have a crisis, but the issue is which crisis? Which crisis do you think most people think about? There it is. Okay, that's what confronts us, at the takeout store and the supermarket, and we're up against very powerful media interests. Some of them are opposed to the idea of climate change. Some of them are just concerned with getting on and making money. So we have to compete with some of this kind of work. And so I've become a little more radical than I used to be in terms of trying to get out there. I haven't got myself arrested yet, like some of my colleagues at UBC, but scientists are getting there, right? They're getting desperate. So I thought we'd go through a little sort of a journey into the future, both using visualizations, but also, what is the future of future visualization? And where is it going? Where does it come from? And where might it lead us? And I'm going to start with issues of really our choices and what our role might be as scientists, as researchers, as experts in our field. I really believe we have a moral obligation to be doing this work. Visualization is good, visualization is nice, visualization can be helpful. Does it matter if it's used a lot? Well, I think it matters hugely, and I think it needs to be used a lot more and probably a lot better. Because I just don't see the solutions coming fast enough for the problems that will land on our children's and grandchildren's lap. So how do we help, particularly communities, make these difficult choices about futures? And it really starts from the fact that, in my experience, most people I talk to who are outside our field have not thought about their holistic futures. It's not something most people have ever seen. Their community in the future. How many people go to planning meetings or civic meetings? Not many people. So back in 2005, was it? Eckhart ran the second Ascona conference. It was our shared landscape, was it?
Yeah.
And in that talk, it was just when I was getting motivated, and I used a slide that said, it's not just about doing better images, it's about changing society. And I still, unfortunately, believe that's necessary. It'd be nice to leave it alone, but I think we have to. So that's my preamble. The other points I really want to make is just briefly review where we call it climate change visioning, but there are, I'm sure, better names out there. The idea of looking at futures with climate change, using the kinds of tools that we know how to work with. And how well does it work? So this idea of evaluation, of effectiveness, are we far enough along that we can actually measure some results, and what does it tell us? So I'll briefly review some of that, talk a little bit about what guidance is available at the end, and also from what we've learned so far, and talk a little bit about some of the new directions that I see. So, as many of you are in landscape visualization or landscape planning, landscape architecture, even urban planning, visualizations have been around for a while, and they've been used for many, many decades. And one example that really brought it home to me was one that John Lewis, my PhD student from a few years ago at UBC, he was working with the Chiam band, which is a First Nation Aboriginal community, and he was looking at existing scenes like this, which to us looks like a pastoral landscape of dairy farming, quite pretty in British Columbia, the Fraser Valley, and to the First Nation culture was an anathema, because this was supposed to be prime salmon streams, shaded, forested, densely forested, and they were struggling with how to solve just very simple land management problems. He took in a whole bunch of visualizations, but some of them looked like this, basically restoring the native vegetation along the watershed, putting back the shade, addressing some of their spiritual values. And we sat down, we did an evaluation with the elders and members from the community, and some of them had tears in their eyes. They were highly emotional. One by one, he sat down with them, spread out a little image, it looked like this, and the relief was amazing. It was tangible. The emotional content was huge, and that really affected me, it affected John. And to see the power of essentially Photoshop and Visual Nature Studio applied through a participatory process with First Nations. So, in trying to attach that then to climate change and much bigger issues, much harder to solve issues, we started looking around for other precedents. And of course, The Day After Tomorrow is probably one of the best documented, most famous, one of the earliest ones that came out. What can we learn from the power of that movie? And it has been studied, so we were able to use actual evaluation results from that. But essentially, we sort of felt like it came down to sort of three things, two of which are captured in the movie. Disclosure, what's happening in the future? What could happen? Drama, the power of flooding the Statue of Liberty. This is obviously dramatic stuff. That's why people spend the money and go to see movies. But what was obviously missing was the third one, defensibility. So if we're going to take people into the future, into 4D visualization, the fourth dimension, we've talked a lot about this already. The defensibility is pretty key, and it relates to some of the other presentations you saw today. Other precedents that were emerging around the same time. This is some lovely detailed climate change projection scenario modeling out of the Environmental Change Institute at Oxford. Pam Berry's work, where they've got these lovely Ordnance Survey maps that plot every field, and they've got models that can change the crops in every field and run this out, but we were never quite able to put it into 3D. Or Olaf Schroth's work, working with Eckhart and David Miller on the Vigilance project. So this one over here, showing the change in fairly simple terms of where the snow line is now and where the snow line will end up being with climate change that affects the ski operators in Switzerland. Again, he had a dramatic effect in those workshops when he showed these images. And others that are somewhat more scientific, but not particularly, early studies from the UK of different renewable energy landscapes to sort of get people talking about it, but without any modeling. So lots of bits and pieces that people were starting to work on, and other people at UEA as well. So we had sort of the bright idea of saying, well, okay, what if we did this and this and this and this and this and threw it all together and sort of threw it at the public using landscape visualization as the primary but not the only medium. In other words, sort of go for the jugular, listen to the psychology, take the modeling, have it be defensible, but make it emotional, make it personal. What happens? Can you actually do it? How would you actually do that? It's a lot of stuff. But that was sort of the goal. It was rather ambitious, probably naive. Well, it was naive. But to develop and test new decision support tools that build on the modeling that exists, build on existing data and using visualization. The goals being to build awareness, to help decision makers to some extent, maybe even affect behavior. At least in an experimental condition where we can test it. And our little mantra became localize, spatialize, and visualize, bring the science that was primarily global or national at the time, bring it down to a regional level and then push it down to street level. People's backyards, using landscape visualization, but connected all the way through models or frameworks. That was the goal. We did some homework. We decided that it had to be quantitative and qualitative. We're going to address emotional issues and step over that boundary. That's what landscape visualization allows us to do, is to get into this experiential territory. And I've written in a couple of places that it's an important thing for scientists to grapple with and understand, and it's a reason why they're uncomfortable, is it takes you there. Whether you want to go or not, it's going to take you into emotional, contestable, fuzzy territory. But this is the stuff that stops the solutions, what would otherwise be an engineering solution or a scientific solution. But at the same time, if it's spatial, then we have the backup. We have XYZ coordinates. We have models that will run, and we can populate them. And we wanted to be expert and participatory, taking local knowledge, local stakeholders, as well as the experts and the scientists. Get them all around the same table, co-produce some of the knowledge, and co-produce the visualizations. That was something else I really learned from UEA, where they talked about it, although I'm not sure they'd done it at the time. Do stakeholders have a say in the visualizations that are prepared? And we wanted to find a way that we could allow that. And of course, exploring alternative pathways and making it local. And the last part, obviously, is evaluating the impact. So we wanted to measure the effects. So that's what we set out to do. And I'll show you a few examples of what those look like. And then I'll show you some of the research results we found so far. And there are more people doing this now as well. So I'm hoping some of these other examples can be sort of fed into this growing knowledge base. So I live in Vancouver, and everybody in Vancouver knows this view very well. This is the North Shore Mountains. Everybody on the waterfront in downtown Vancouver looks at this. How many people have been to Vancouver? Quite? Oh, okay. Well, you don't come and see me very often. You should come more often. But anyway, so many people know this view. It's iconic. And we were lucky enough to be working with some scientists from Environment Canada who were doing, we asked them to do as part of our research project, some statistical downscaling, which is all that they could do, of the regional climate models and the global climate models. And so this is an A2 scenario from the IPCC ensemble. Here is an elevation axis, here's time, and basically this blue squiggly line, a classic scientific map of a trend going up, is that average height of the snowpack in the spring, which is a key date for the water supply for the entire Vancouver area. And so all we did was strap those two things together as one example of this kind of work. So as we run through, we'll do a little bit of time travel, as Olaf likes to call it, and we'll run up to 2020, and you'll see the snowpack rising or diminishing. In other words, shrinking back to the mountaintops due to global warming, locally refined. And so by 2100, we actually have a pretty small snowpack in springtime. Doesn't mean necessarily in winter, doesn't mean every year. Some years we're going to have these extreme conditions, but this trend is pretty obvious, but not very compelling. This, we've had council members in North Vancouver say you saved us 6 months of debate with our council because they got it in 30 seconds. And so it's a very simple, classical, iconic example. It's been used many times now of what value you add to perfectly good science that isn't powerful enough by itself to get across. Okay, so this requires a process, requires a structured process that we mediate, but we try and be sort of in the middle, a sort of hub, and we're drawing on a lot of resources. So participation, first and foremost, forming local working groups with local stakeholders. And so we're doing this in a specific community. So we've done it 5 or 6 times now in different communities. But in each case, this is a locally based project. Getting local participants, then crafting and building scenarios of some kind, integrating the best available data that we could find. Sometimes those are models, sometimes they're sophisticated, sometimes they're very crude, sometimes they're just GIS analysis. And then applying it to 3-dimensional visualizations with a fair degree of realism, though that varies, and taking it into the future. So the collaboration part really works in 2 phases. One is the actual generation phase, where this is where input is given to the scenarios, to the visualizations, to the viewpoints, to the imagery, through a local stakeholder working group. And then the evaluation with a larger public group at the end to sort of see what the effect might be on the larger population. And in a few cases, we've been able to measure that quite precisely. I won't bore you with the process, but suffice it to say, this is landscape planning based, it's iterative, and it is holistic. And all these components of participation and data and models, and actually, of course, producing the imagery and the maps and the other graphics, not just visualization with 3D, goes through these multiple phases. so that you can verify the draft visualizations. You can get input on the scenarios that have been generated. And it's not us as experts, here you go, here's your future, what do you think? It's a mediated process. And again, what we had in the back of our mind is there's deniers out there are skeptics, I want to get peer-reviewed papers, there are all these people who are going to criticize this process. How can we make it, not ironclad, but as tight as possible, as defensible as possible? And so structures for bringing together scenarios so that somewhere in the scenario set, we would have things that talk about the causes of climate change, the impacts of climate change, the adaptation measures and the mitigation measures. Maybe not all sandwiched in one scenario, but addressing these pieces of climate change that are sometimes disconnected. And in my book, I go into great length about why it's important to put those together. Okay, so this is perhaps one of the key slides that maybe helps explain the process. It's hard in even sort of 40 minutes to really explain how these things physically get done. But this is perhaps this was actually the first example, and it was also the most sophisticated because we found out it was quite an involved process. We were lucky to have a true regional socioeconomic model. It's called the GB Quest model, Georgia Basin Quest, that John Robinson originally created a few years back. And we were able to adapt and modify that to give us some core spatial outputs for the region of Metro Vancouver. And then run it through three different emission scenarios that relate back to A2, B2, B1, 450, a stabilization scenario that links back to the global scenarios for carbon and climate change. And there were many other metrics, I'm only going to show you this one. But it clearly shows, the thing we were really trying to get at was, what does a high carbon world, based on what we're doing now, look like? And how does that compare with a low carbon world that would meet, say, a 2-degree limit if the whole world did it? And we had to make huge assumptions like the city of Delta, this is a part of Delta that we're looking at here, does what the whole world does. So the whole world signs up to Kyoto, the whole world signs up to all these things that they should have done at Copenhagen. And we get to a sort of a 2-degree world and the emissions drop precipitously by 2050. That's our British Columbia target. We are quite unusual in North America. We have a mandated legal target, which is quite aggressive. And unfortunately, most people have no idea that we actually have that target. This is a profoundly different world than this world. How do we get that across? What's the spatial footprints of it? How does it vary? So, for example, this is high growth, high sprawl, which you get in lots of places in North America. Single-family homes is where the growth goes. This is the yellow, what we call World 3. This is World 1, World 3, World 4. In World 3, we're doing sort of the right things, but we're still growing too fast, and we counteract the improvements that we're making through things like density and renewable energy. And then this is the one with a lower growth target, really green policies brought in early and quickly to try and get this carbon reduction. And we sort of hit upon this naming of 4 or 5 scenarios, 4 in this case, and we found the public really gravitated to World 1, World 2, World 3, World 4. They got it. They were far enough apart that people could understand them and not get confused. We leapfrogged over the rest of all the uncertainty issue. This was enough. We felt there was enough uncertainty here already. Something we could talk more about. Okay, so that's kind of the idea. Any sort of big critical questions just on the sort of generic process as we first did it anyway, and it's been adapted since then. Okay, if I haven't lost people, that's, I guess, good. Okay, so that first study, which took about 3 years, used that regional socioeconomic model. And we did it for 2 communities, North Vancouver and Delta. North Vancouver had the snowpack issues and many other issues. Delta had primarily sea level rise issue and other adaptation issues. And then we also have since worked on it with smaller budgets and less rich modeling in other communities, which has actually been even more interesting because now you're dealing with real constraints that planners might face. I don't have time to go through all of them, but I'm going to talk about Kimberley, which is an interior community in British Columbia, And we did a very interesting but quite different Arctic study, and I'll have to tell you about that another time. So just a couple of images from North Vancouver. Here's the snowpack again. Usually I do a little quiz, which is more compelling, the 3D perspective view or the plan view. But anyway, here's the plan view of the same thing, 2020, 2050, 2100. Right? That's, again, springtime snowpack. This is Grouse Mountain. This is where we send our kids to ski after school in Vancouver. And you don't do that in March in a typical year by the end of the century, obviously. Perhaps soon. But then also bringing it down on the ground. And one of the things we were interested in exploring, and we believe in, I think firmly, is not to use any single form of visualization. So this is Photoshop. That was VNS based on spatial GIS mapping and the projections. That brings some problems with it, which we can talk about. But we wanted to use a range of tools that address different issues. And this one is an existing, rather lovely, very expensive, very high carbon footprint neighborhood in North Vancouver. And how would we get that into World 4? What would we have to do to retrofit existing communities? Because we all know the biggest problem is existing communities, not the new stuff. And so we played with it using examples of things that all of which have been done somewhere else. There's no modeling here, only visual modeling. But the idea that we can make real those things that have been tested elsewhere but never been put together in one place. And again, this is one of the sort of sets of images that have gone round and round and round, been used in the media many times, as a way of opening up people's eyes, saying, well, does my neighborhood have to look like this? And what do I pay? What does it cost me if we go greener? And so it raises all kinds of issues that I talk about rather obsessively in the book in some parts, I'm afraid. But nobody in these suburbs, until very recently, would be seen dead with a 7-Eleven or a grocery shop anywhere in the community. This is single use, this is residential. We don't want drugs, litter, noise, more cars. We want our car, we don't want their car. So this was very controversial then. It's a little less so now. Turning houses into sort of apartment buildings. These are huge houses. There's plenty of square feet. Tertiary, secondary tertiary, 4 suites, 4plexes. That's just become legal 2 years ago. It wasn't legal to have secondary suites in this area, in this zone. Electric cars, loads of them in North Vancouver and West Vancouver. They're all on the golf course. Illegal on the street. Right? So this is what sort of triggered this whole thing. It's probably why I wrote the damn book. All these solutions, not only are they not sort of brought forward, they're suppressed. They're actively suppressed. So there's this huge transformation, and there's many other things in here you can see, including some adaptations for green infrastructure, etc. Very quickly done. I don't know, it took one of our students a day or two with some review, etc. to do it. But a very powerful set of stories. And then, we can get people to sort of think about what those options really are. And then in Delta, where we've done the most work, we worked there for about 7 years now, and we built a real trust relationship. But this is some of the early work, and I'll show you a few examples of the later work in a minute. But again, following through these 4 different worlds, world 1, high carbon, sort of existing trend. World 2, which you'll see in a minute, is where we only adapt. I naively thought that local communities would only want to adapt because the tragedy of the commons, we don't get the benefit of mitigating, put our money, put our effort into adaptation. So far, that hasn't actually been the case. But we didn't know that going in. World 3, where we do everything right but too slowly, and so we don't actually get the carbon reductions we need. World 4, where we do everything right from a carbon reduction standpoint, and we increase our resilience because we're still going to have a lot of sea level rise. We had, in this case, modeling of sea level rise numbers from another agency, so we had quite a lot to work with. So here's the existing community. This is an actual real community in Beach Grove in Delta. And in our working group, we had a couple of residents from here. We changed the buildings because we were worried about being sued. So and property values, which is a real issue, although it hasn't come up here. But just to be on the safe side, we didn't use the actual buildings. We used very similar generic buildings. So let's just have a quick walk through these 4 worlds. I'm compressing what took essentially the best part of 2.5 years to do, although we were doing 2 of these at once. And lots of data and lots of thinking, so you're going to see in this awful telescoping down in sort of 45 seconds what took 3 years to produce. But it's the tip of the iceberg, but it's the powerful tip of the iceberg. So here's the quote-unquote doom and gloom scenario. I'll try not to use that term, but that's what people think. Flooding, they had a flood like this the year we were doing the study. It's a flood-prone area. It's flooded before. It will flood again. And so they were actually quite used to floods. And what we were showing here was a fairly dramatic vegetation change. Only the willows have a chance of surviving because of salinity, even without the flooding. And we would lose houses eventually. But this image was actually criticized in our responses for being too benign. So the actual floods, the waves were actually much worse. You're not showing it's not scary enough. But okay, we survived that one. But I'm always being criticized for being too cautious. But first time out, we didn't want to take too many risks. Or the obvious one, we'll adapt. We'll raise the wall, which is actually hard to see in this view. But hold on, I have one of those coming too. So you might think that's a simple solution, but there are issues with it. And so we looked at another variation of World 2, which is probably more robust because a large dike, although very expensive, big trade-offs, is safer to protect against sea level rise in the long term. But you can begin to see what some of the trade-offs might be to a community, how interesting this would be if you actually lived on that street. And also some of the design issues that immediately come up. So this is an earthquake zone. Can we really design buildings on stilts? Is that an effective option? So this is a great discussion starter, dialogue starter. And many people around Canada and North America are doing this kind of work. We're not definitely the only ones. But you can see retrofitting here, for example, combining adaptation and mitigation with solar panels in this case. And then a really rather futuristic example of various ways that one could achieve World 4, doing more with local units, with units that could rise or float, or that have renewable energy, renewable food, and local resources inside the communities. And we've since done quite a bit more work to sort of articulate those kinds of things. But anyway, stretching those 4 worlds out and giving people the idea of, whoa, I could really change this if I wanted to, or what would I give up if we do make that change? This was the issue of the wall, and this is, I think, illustrates how landscape visualization, when you're on the ground, in someone's backyard literally, can help explain what have become critical barriers to the imposition of things like adaptations, which you would think everyone would want. Nobody in this community wants higher walls for this reason. Right? They lose their view, they lose the quality in their garden. They don't have to have a totally ugly wall like that. But they're there because they want access to the beach and because their families have lived there for many years. And they've always had that lovely open view from their home and from their garden. And so this is a very big thing for them, and it's why they've turned down previous attempts to do adaptation. And why the city of Delta, the politicians live in fear of their community because they know what they should do and they know how much debate and controversy there will be when they come forward. Okay, so some of the results that we got, I'm just going to cherry pick a few examples. There are a couple of published papers and a couple more that are still waiting to be published. Got to read that on the plane on the way home. So we get a lot of comments like these. These are quite typical. Numbers may not stay with me, but the visuals will. I learned how things would affect me. My community, this presentation placed my community in that context, relating their gardens and their streets to the penguins and the polar bears and the Mount Kilimanjaros and that kind of stuff. And this wasn't always said this way, but people seem to really appreciate that someone was talking to them about a range of possible solutions. And that had never happened to them before. And most communities, it's still not happened, right? They don't actually know what adaptation means. They don't know what it looks like. They don't know if they have 2 or 35 alternatives. So just getting that array of options out there to people seemed to be a profound, something that they really appreciated for that. So we measured quantitatively as well a number of different issues with questionnaires and interviews and observations. So we tested some practitioners. We also tested the local publics, but this is one example from the practitioners. And we did a pre-post fairly standard social science evaluation before and after, essentially a 3-hour workshop. These are pretty intense workshops. We throw a lot of visual stuff at them to keep them awake, and they stick with us, and at the end we get them to do a questionnaire. And so you can see, before they went through the workshop, these are practitioners, engineers, planners, landscape architects from the region, that the majority felt that impacts of climate change are serious in about 20 years. And that shifted statistically significantly to almost half felt in the next 10 years as a result of that particular session. Now, there's biases in there, I'm sure, but it is a fairly significant shift. And with practitioners who we actually assumed would know all this already, they seem not to be quite so aware of it. And then we've done a number of these kinds of studies. In Delta specifically, we found various measures that show that people were obviously learning a lot about local impacts and also local adaptation and mitigation possibilities, as I've said. And some interesting numbers that would be interesting to a local politician based on what they tell us, and this is self-report from a group that was mildly interested in climate change already. Increased willingness, almost 2/3, increased willingness to support local mitigation adaptation measures by self-report. And if I was a council member, I would want to go out and perhaps verify that and do my own poll, but find out, or have focus groups or something to find out, is that the pulse of the community? Is that what they're thinking? Because the politicians think they're out in front and are afraid to move faster. We've also just completed a longitudinal study, the first one we've done, about 4 years later, and this was just with our working groups because we couldn't go back to the members of the public, unfortunately. But one of the big things we got from the local government staff was that they felt much more willing to consider what at that time were radical solutions. Because there was somebody else, in this case a university, putting forward credible information and with enough sort of oomph that they could sort of ride the wave a bit, right? And they were things that they were already believing, didn't change their minds, but it gave them, emboldened them a little bit, gave them more confidence. That was, I think, perhaps the biggest thing. We didn't find behavior change. We didn't find really much in the way of specific policy change, but there were a lot of other things going on at the time. This was all around the same time as Al Gore and everything. Pretty hard to determine that, really. But we did find some specific studies that spun off, and there's been widespread use of visual imagery in the community. There are a lot more results that aren't published yet. I'm waiting for a master's thesis to be completed, but it's almost done. So that will be coming out soon. Okay, so just to bring you up to date with Delta, just a few slides from the latest round, and this was a spin-off from the earlier work. We managed to get some additional funding, bring it back to the community, and say, you have a real adaptation issue here. Here's some adaptation funding. Would you partner with us again to really help you figure out how to bring stakeholders forward and move this through this contested decision space of, do we raise walls? Do we do managed retreat? These are issues that they really didn't want to talk about, weren't comfortable with. And we were able to get managed retreat on the agenda. It's now been out in the public, again, through a sort of a third-party, but very collaborative approach. And we weren't sure if we'd get away with that, really. But it's obvious, and yet people don't want to talk about it. So just a couple of examples. Here's one of the existing areas where the dike is along the road in Ladner, one of the communities. We already have a fairly substantial dike already there. It'll get even higher when we follow the new provincial standards. These are going up by meters in some cases. So pretty profound impacts, including loss of the main highway through town, because that's where the dike sits. So these are big issues that people have to think about. And then another example is the managed retreat. issue or coastal realignment issue. Here is it's that same Beech Grove neighborhood, very flood prone. It's just simply going to get a lot worse over time. And one of their options is to retreat out of that area and retreat back into the highland up here, which presumably would densify and become lower carbon. So this idea of sort of knock-on effects to other parts of the community, really no one had given any thought to. And those aren't necessarily easy things to talk about. But at least it's out there as one of 4 alternative scenarios, all equal, none of them any more probable or desirable than another. These are 4 sort of logical alternatives from a set of many others. Okay. So I just want to show you a couple more examples from the third case study, which is the Kimberley project, where a very different setting. This is up in sort of the mountains, quite scenic, and we didn't have a lot of money and we didn't have much modeling. We didn't even have proper climate change projections, which is a huge issue for most communities, certainly in Canada. Most of them have no climate change projections that are local. Massive issue. But increasingly, the regional trends are becoming clearer. So here, for example, we've got a few things that we were able to do with the data that existed. So we did some spatial modeling of pine beetle and fire risk based on the existing forest stands with advice from forest experts. So we could model the high-risk areas, which are in the watershed, which, when they go, mountain pine beetle takes out all the pine trees at once, basically, which it has subsequently really done. And that will increase the runoff. Here's the town in the watershed. These blue areas in here are at considerable risk. Oops. Considerable risk of flooding. It's already known. The engineers know all of this. But this is an issue of explaining to the public why we might need some fairly major interventions in the heart of town, and that these things all connect. Olaf Schrother worked on this, did these things with Google Earth using an existing model of it's called Farsight. It's fire spread mapping. It's a very fire-prone area. There's forest all the way around the town. Here's the town where we were looking, and all of this is the main highway out. Here's a hypothetical fire spot, and in 4 hours, it's cutting off the main part of the town exit route, and in 8 hours, nobody can get out of town because it's gone right through the town. The fire models don't know how to handle buildings, so they just ignore buildings. But we know what would happen. It's going to go through. So when we presented that in a workshop, there was an audible response, put it that way. This was a report, there was existing data, it was public, but the public hadn't really seen it, and it was only at this workshop that they sort of got it. And so Olaf and Ellen, the people who were working on it, were able to sort of record this big spike of concern, and it's now led to a lot more fire management, fire protection policies. And not that hard to do in this case. It doesn't take a lot of money, it's just using Google Earth and existing data. We didn't have the time or the models to go through a real complex scenario analysis, so I put this in just to show that it doesn't have to be the Cadillac, it doesn't have to be all the right things. We loosely grouped 2 scenarios, an adaptation scenario, which is really what the funding was for, and we squeezed in mitigation because we felt we should. And got them thinking about some of those issues. And we made some very coarse assumptions about where those fit on the IPCC type scenarios. And then just basically gave them very simple diagrams, maps, sketches, whatever we could produce quickly with a few landscape architecture students in a structured process to pick out some of the things like how you'd adapt to those flood areas with parks and shade trees because it's getting a lot warmer. How we could begin to put in transit systems and renewable energy using the biomass thinnings from the fire reduction. So very, very simple, very quick, but managed to get that through a process and get it into a plan that was adopted. One of the things that Olaf did was to evaluate the use of Google Earth. We heard a little bit about virtual globes earlier today. And it's just a fancy name for things like Google Earth. But essentially, what he found was really a bimodal distribution of people ranking how useful the Google Earth, the interactive, hands-on interactive stuff was. And 4 is the lowest, not very useful, 1 is the highest. So a whole bunch of people really liked it. The dynamic, they could even play with it on a little booth off to the side and really get into it and do all that interactive stuff we heard about. A sizable group, almost a third, didn't like it. They liked the static stuff. They liked the PowerPoint, they liked the posters, things that they could look at slowly. We didn't have a big enough sample. I can't tell you if they're old or young or gender specific. Interesting questions, but we didn't quite expect that. So the idea that multiple media is safer than any single media. We have different visual learning styles. But this is a more typical result that we've got in nearly all of our, actually all of our studies have had some sort of distribution like that. If you just simply ask a question, how useful were the visualizations? Sometimes we've compared maps and visualizations and graphics and other things. But typically we get, a pretty sizable response, 80+% that say yes, it was helpful, either very helpful or somewhat helpful. And we've had real measures adopted from that plan. Okay, so I'm drawing to a close now. You'll be glad to know. And since there's been since that time, not only our studies but many other studies that are being pulled together that are going in this area in Canada. And I've talked to a few people here today who are doing things like that. It is, I think, important to sort of know where communities and extension agents can go to sort of get at least the latest. This is a moving target. All of this stuff should be considered interim, in my view. But one of the ones that we put together a couple of years ago that Alan Pond led us on was the Visioning Guidance Manual. This one's free. It's on the website. I think I've got the web. Yeah. On the CALP website, you can download it. It's a big download. It's a huge PDF. And we also have a few online modules. So things like this are starting to fill that enormous gap of how could you possibly begin to do any of this stuff. And to me, it's adding value to what people should be doing with good planning, but obviously often don't have the resources or the training or the inclination to do. So resources starting to appear. We'd love to get comments on this. There's all kinds of things we've changed already, but at least it's a start. And then let's see, it's changed my formatting a bit. As Joan said, there is the new book. I have a few copies around if someone wants to reduce my load on the way back, reduce my carbon footprint when I fly back. So this only just came out about a couple of months ago. It's got a number of things in it, reviews various kinds of visual media, not just 3D visualization, and it also tries quite hard to let an average community member or a council member put their own community into the frame of climate change. What does climate change look like? And how can we use these different kinds of visual learning tools to bring the community along or just to understand it better? And includes the code of ethics, which is sort of evolving on how to use visualization ethically and responsibly. And as I say, there's some flyers floating around, some of you may have seen, with a discount, and I'm happy to do that a Fugo authors discount if you like. Your question was about signatures or something. I don't think it adds value, but I'm happy to do a signature. I just don't want to take 8 books back. I've got to get rid of 3 or 4 if I can. So in the book, I do some fairly general principles, and again, this is culled from many people's work, and every time I do it differently. I keep searching for a better way of doing it, but I think it boils down to various media about that clarity, that vividness. Going back to that, the crisis cover. Like, you've got to grab their attention, and the message has got to be clear. Credibility. Without that, there can be an effect, but it isn't always what you want. And certainly, you're going to be open to criticism. Again, it's got to be really engaging in the sense of giving people something that they can work with. It's interesting, it's accessible, it's not hidden. You don't have to dig for it. And I think this is the key one that I think that we've not done a very good job with generally. Has been connecting it by place, by appealing to personal values, to local identity, and connecting things that were previously disparate. And that holistic kind of landscape view, I think, is the way to go. And then, of course, one should never forget feasibility. It's got to be replicable. It can't be just once every 10 years at the university. A whole bunch of examples. I'm not going to talk about them, but a range of things like thermal imaging is very powerful. Some of the more popular iconic visualizations that have been used to good and lesser effect. And a couple of slides just to sort of show you where some of the new directions are, and many people are doing this now. This is going to be our first take on it. So actually, a second take on it, because we have a Future Delta 1.0 video game, which is a prototype building on scientific data. The new one will be, we've got a bit more resources now, essentially modeling that same area that we looked at, where they're dealing with flood issues and they're dealing with energy issues because they have an energy and emissions plan to implement. How do we get the public engaged? We're going to go through the 10th grade science students, try and get them engaged in a game that's really fun. We're hoping to get EA, Electronic Arts, involved. And using the gaming expertise, which is not my expertise, but working with people who have it, to really see if we can make this thing work and fun and get to the parents and to the council that way. And then the other big experiment that we've been working on for 10 years, it's now built, I'm glad to say, is the Decision Theatre, or the BC Hydro Theatre as it's called, at the Centre for Interactive Research on Sustainability, another big mouthful, at UBC. Greenest building in North America, they say, right now. But this is a space where we can essentially play and do all of these neat things, but with large groups or small groups. Immersion, touch tables, multiple iPads, games, etc. It's not a Calc thing, although Calc designed it, but it's run by the university, and it's a big experiment, and we hope people will come to it. I hope remotely, because, as you know, we should do meetings like this a lot more often, but we should do way more of them virtually. So I just don't want to go to too many meetings, much as I love areas like Maryland or Australia. I just don't want to go there very often. I just don't want to fly there, but I want to be able to go from sitting in here, right? And we have to find better ways of being able to do that and make it feel like we are there. So there's some high technology out there, but we want to do it with sort of cheap and simple, but still capture these collaborative things a little better. Okay, so I'll finish up. We've got to grab their attention. I'm experimenting with graphics like this that try and make connections that people don't want to make. We know we can grab attention. We know that visualizations, good or bad, grab attention. We know that they resonate. They stick in people's minds years afterwards. We know that. We've measured that. And we've certainly seen places where it accelerates learning and even has some effects on policy and action. And in the literature, you can find behavioral effects too if you look carefully. But they're spotty. I think we do have a moral imperative I'm not saying the way it's being done now is the right way or the best way, but I think we need to do a lot more of this. We simply don't have the time to sort of wait 10 years to figure out good ways of doing this stuff. I really believe we have to scale it up when that means training, capacity building and extension, and getting local communities and local governments and regional governments doing this kind of work. NGOs, industry, I don't care. Just because the stuff works and it's better than what we're doing now. It may not be perfect, may have real problems with it. But we've got to start moving if we're going to take climate change seriously. If we decide not to take climate change seriously, fine. But don't tell me that we didn't try and tell you. Don't tell, oh, you never explained it like that. Well, we did. We can't force people to do anything. But I think laying out choices for people to make is absolutely essential. So, and of course we have the imperative to do it right, so I think we should be working on these principles, adapting them, adopting them, getting them built in, and using processes. I forget who it was, but somebody talked about it's really about process, not so much the technology, it's not even necessarily the imagery, the process that it comes in is a big part of how it stays credible. And of course, we need more research, not because we need more research money, but we need better evaluation, we need better results to know how well we're actually doing. And I am going to stop right there and say thank you to 1 million people whose work I've been representing, and hope we don't get to the last little ice floe and the last patio heater. Thank you very much for listening.